Hi, welcome back. Once again, I'm welcoming you all to this beautiful online learning platform, An Academy. An Academy is the India's largest online learning platform. I'm welcoming you all to this. Now we are happy to announce that An Academy is going to providing online training for GATE and engineering service exams. GATE and engineering service exams. Okay, with India's best educators. Here, about myself, I G Venkata. I have 16 plus years of teaching experience. So far, I mentored more than 60,000 students for their GATE examination. At present, I am pursuing PhD from JNTU Kakinada and my specialization is VLSI domain. Now, first here we check how to get an Academy learning app into your device. Just go to Play Store, type An Academy. By typing An Academy, it will show the An Academy learning app like this. By clicking on this install button, it will install the An Academy learning app into your device. Now, what you will get by joining An Academy, what you will get. First and foremost thing is daily live classes. Every day you have a live class. Next, structured courses, live tests and quizzes, unlimited access. First we check this daily live class, what it means. See, every day you have a live class. The intention behind to conducting live class every day is always to keep the student in touch with the subject. Now, in that live class, you can chat with your educator. That means you can chat with your faculty. You can engage in discussions and you can ask your doubts and answer the polls. You can perform all these things while class is going on. Next one is structured courses. Whatever the course here we have, all our courses, not only single one, all our courses are well structured with your exam syllabus. Okay, with updated exam syllabus, your course is well structured in line. Means first what subject has to prepare, after that what subject, after that what subject, in that subject also what is the first topic, what is the next topic, what is the next topic, like that it is arranged in a proper order. Then it is very easy to the students to pick the respective and the right topic at the right time. Okay, now then student can prepare best. After that, live tests and quizzes. See, once you complete your preparation, you can evaluate your preparation by writing regular mock tests and quizzes. By writing regular mock tests and quizzes. Okay. By regular mock tests and quizzes, you can analyze or you can evaluate your preparation. And after that, we do the detailed analysis on your performance. Detailed analysis we will provide on your performance. After that, unlimited access. See here, it means once you take in a subscription, you can get access to all our live and recorded courses. You get access to all our live and recorded courses and you can watch from the comfort of any of your device. You can watch from the comfort of any of your devices. Okay, these are the benefits you get. Now, there are two subscriptions, iconic subscription and plus subscription. Plus subscription is the basic subscription. In this, just before, what are the things I explained? Daily live classes, structured courses, live tests and quizzes, unlimited access. What are the things just before I explained? You get all these things just by taking plus subscription. You get all these things just by taking plus subscription and iconic subscription. Iconic subscription is the next level of subscription. We take your GATE and engineering service exam preparation to next level with a personal coach. Your personal coach is nothing but a top exam expert. He is the top exam expert. First of all, what are the benefits got by the plus subscriber? Daily live classes, structured courses, okay, all these things you get all the benefits. The benefits which are got by the plus subscriber, you get all those benefits. Daily live classes, structured courses, live tests and quizzes, and unlimited access. All these things you get as a iconic subscriber. All the benefits got by the plus subscriber, you get all this. In addition to that, you are getting personal coach, study tracker, mains question and answer practice, mains question and answer practice. Okay, now what is the concept of personal coach? Here you get one-on-one guidance from top exam experts, from top exam expert. He is acting as your personal coach. Once you attempted a test or a quiz exam, based on your performance, that means he analyzes your performance in that topic you are written effectively and which topics you are getting low marks and where you need more preparation. Everything, they analyze your paper from top to bottom, and based on your performance in that, they prepare a proper study planner to you. At the same time, the respective study material also they will provide to you. Okay, all these things you get from your personal coach. Okay, after that, study planner, study tracker. Now you can evaluate your progress in weekly reviews with your personal coach. Okay, you can evaluate your progress in by weekly reviews with your personal coach. So for that, you need to participate in study tracker plan and study booster workshops. For that, you need to participate in study tracker plan and study booster workshops. Okay, after that, mains question and answer practice. Mains question and answer practice. Here in engineering service exam, you need to write a paper that is a mains paper. In that, you need to answer the question in a descriptive manner. For that, you need a regular practice. Okay, and you can strengthen your mains answer writing. You can strengthen that by regular practice with evaluation and personalized feedback. See, it means once you've written the exam, we analyze your answers, and that means we evaluate it and we give the feedback on that. By taking that feedback, you can identify your gaps in your preparation and you can fulfill those gaps. Okay, so all these things you get in iconic subscription. These are the things you get. Okay, next. Okay, plus subscription already we discussed. Now, yeah, see, there is an academy combat is going on. An academy combat is going on. Now you can compete, crack it and conquer it. See, it is the India's largest online scholarship test for GATE exam. In the test, if your rank is between 1 to 3, if your rank is between 1 to 3, you get the complimentary An Academy Plus subscription for 1 year. Complimentary An Academy Plus subscription for 1 year. And if your rank is 4 to 10, you get 75% off. 75% off you get on An Academy Plus subscription for the tenure of your choice. And if your rank is 11 to 50, you get 50% off. you get 50% off on an Academy Plus subscription for the tenure of your choice. If your rank is 51 to 100%, then you get 25% off. 25% off on an Academy Plus subscription for tenure of your choice. So here tenure is either 6 months, 12 months, 18 months or 24 months. Okay. Now about this combat, it is the India's largest weekly competition for GATE. India's largest, don't forget that. And you can assess your GATE preparation in 60 minutes. And we are challenging that original GATE questions you get, which was curated by the best educators. And take it live to compete with the best. Super fast fun with All India Live Leaderboard. And after that, we provided detailed video solutions to you. In that, you can identify your weak areas while writing this exam, and you can strengthen that area through this detailed video solutions. And the next combat is coming on May 9th. Don't forget that. May 9th is your next combat. Okay. And it is starting at 11 a.m. Don't forget that. It is going to start at 11 a.m. And these are the different eligible branches: mechanical engineering, civil engineering, electrical engineering, electronics and communication engineering, computer science and IT departments. To unlock it, use my code VRAW10. To unlock it, use my code VRAW10. Now, this is the guide for enrollment for the scholarship test and to success the scholarship. To get in scholarship test, first enroll for free from your Android mobile. After that, appear live for the test. Attempt the test. After that, you get the video solutions. You can view that video solutions, practice those models effectively, and weekly do that one. Every week do that, practice every week. Finally at 1 week, definitely you get the success, you win the scholarship. Okay, so this is the procedure. By following this procedure, definitely you get the scholarship. So now our topic is transistor high frequencies. Already we completed some part of the transistor high frequencies. Now I am going to be skipping that. So CE current gain with load RL, up to this we completed. So we mentioned F beta and Ft. So next one is, we are going to taking the another one, high frequency T model. Okay, high frequency T model we are going to take. Now, high frequency T model. High frequency T model. Now, first take the model. This is emitter. It is base. At output, there is a resistor parallel with a capacitor, and here is a current source. It is collector. So this is going to be Re, and this capacitance is CJE emitter junction capacitance, and this is a CJC collector junction capacitance, and this is a alpha times I1. Okay, so that means this is the current I1, and this is the current IE. This is the current I1, and this is alpha times I1, and this is going to be RC. Okay, and now I am going to writing all the parameters. First one is RE. RE. It is the dynamic resistance of emitter junction. Emitter junction, and its value is mod Vt by IE. Mod Vt by IE. Okay, that is RE. Second one is CJE. This is emitter junction diffusion capacitance. Emitter junction diffusion capacitance. Emitter junction diffusion capacitance. Its value is tau t is the transition time by RE, and the transition time tau t is WB square by 2 dB. dB is a diffusion coefficient of the carriers which are present in base. WB is a width of the base. Width of the base. So these two are completed, and after that RC is the dynamic resistance of collector junction. Dynamic resistance of collector junction, and so its value is 1 plus beta times R naught, and CJC is the transition capacitance of collector junction, or collector junction transition capacitance. Collector junction transition capacitance, and its value is epsilon A by WD, depletion region width at collector junction. Okay, and as usual, alpha is the CB current gain, is beta by 1 plus beta. Beta by 1 plus beta. Okay, these are the things. Now I am going to calculating short circuit current gain of a common base, or CB short circuit current gain. First, CB short circuit current gain. CB short circuit current gain. So simply whatever the circuit we have previously, just I am going to copying that circuit. One thing, I am copying this circuit. Now this is alpha times I1. Now we are going to CB short circuit current gain. I want to calculate that. Okay. Now in this circuit I am going to be short circuiting this. Just short circuit these two. So once we short circuit these two, here what we get is short circuited, and this is going to be our load current. Once we short circuit, this load current is alpha times I1, and my current gain is IL by, this is IE, IL by IE. Okay, at RL 0, we are short circuiting this. That's why I have written there RL equal to 0. Okay, now just simplify that. From this circuit I am going to getting that. Now this is IE, this is I1, and I want to get the value of I1 from that. Okay, so I1 is, just from this part I am going to applying KCL, sorry, current division I am applying. Therefore we get I1 is IE into 1 by J omega into CJE divided by RE plus 1 by J omega into CJE. That's it. Now take this value and substitute here. Therefore we get IL is alpha into, it is IE into, simplify this. By simplifying that you get it as 1 by 1 plus J into 1 plus J into omega into RE into CJE. Okay, take this IL, this IE this side. Now IL by IE we get. So I am copying this equation. Therefore current gain is IL by IE, which is alpha by 1 plus J into omega into RE into CJE. Okay, now here alpha RE into CJE is taken as 1 by omega alpha. Therefore current gain is alpha by 1 plus J into omega by omega alpha, and this is the current gain. Now current gain is alpha by 1 plus J into F by F alpha, we can write, and its magnitude is alpha by square root of 1 plus F by F alpha whole square, and the value of F alpha is 1 by 2 pi CJE into RE. Okay, now whatever the CJE value we have, I am going to substituting that. Therefore F alpha we got 1 by 2 pi RE into CJE, and we know the value of CJE, so that is tau T by RE. Substitute that. Therefore it is F alpha is 1 by 2 pi RE into tau T by RE. These two gets cancelled. Now it is 1 by 2 pi into tau T. That is the equation for alpha. And substitute tau T value also. Therefore alpha is, and we know the value of tau T, transition time it is. The amount of time taken by the electron or carrier to travel from emitter to base, that is the transition time, which is, we know that WB square by 2 into dB, diffusion coefficient of carriers present in base. Now we can write it is 2 dB by 2 pi into WD square. 2 gets cancelled, which is a dB by pi into WD square. That is the F alpha. Okay. Now, by using the regular equations compared to F alpha, F beta, we have some relations. That is F alpha is 1 plus beta times 1 plus beta times F beta. Okay, and we know Ft value already. Ft is h of e into F beta. Now if you compare the relations, first it is 1 plus beta times F beta. So F alpha is greater first compared to remaining. After that Ft is greater, finally F alpha. Sorry, F beta. These are the three additional frequencies or new frequencies we get in high frequencies. Okay. So far, whatever the analysis we applied on this is that analysis is we applied on BJT. Okay. Now I am going to applying my analysis on MOSFET. Okay, we take the FET on that FET. Next, first, before going to applying the high frequency analysis on MOSFET, first we need the high frequency model of MOSFET, because now in engineering service exams you can expect the problems or process analysis on FET. Okay. Now, high frequency analysis on MOSFET. Now, applying high frequency concept on MOSFET. Now, in this, first topic is high frequency model of MOSFET or MOSFET high frequency model. High frequency model. MOSFET high frequency model. In this, first I am taking the MOSFET what we have. Now here is your N plus region. N plus region. Upon this we are placing silicon dioxide SiO2, and upon this metal or poly. So this is N plus, this is silicon dioxide. Okay, it is the channel region. Now here is a gate to channel capacitance is exist. A gate to channel capacitance exist. There is a gate to channel capacitance. At the same time, here is our substrate. Here is your substrate. Next, and this is our source. This is a drain. Source to substrate capacitance exist. Between source to substrate capacitance is exist. Here also source to substrate capacitance as well as a drain to substrate capacitance is exist. Okay, and after that, whatever the gate we have, here is the gate. Between gate to drain, another capacitance is there. Next, gate to source capacitance, another one. And between whatever the overlap, here we have that overlap capacitance also exists. Okay, so this is a gate to, this is overlap capacitance, gate to drain overlap capacitance, gate to source overlap capacitance, gate to source capacitance, gate to drain capacitance. Okay, and this is a source to substrate capacitance, drain to substrate capacitance, and a channel capacitance. Okay, by considering all these things, I am going to writing its model. Okay, I am writing all these models. Now, first one is gate to source, gate to source, including overlap capacitance, including overlap capacitance, CGS, gate to source capacitance. Including overlap capacitance, including overlap. Including overlap capacitance, that is CGS. It is CGS. CGS. Second one, gate to drain capacitance, including overlap. Gate to drain capacitance. Including overlap capacitance. So it is C, by combining these two, CGD, CGD, gate to drain capacitance, overlap also included in that. After that, gate to channel capacitance, gate to channel capacitance, okay, or substrate to gate to drain, gate to source, and this one. Third one is this one, gate to substrate capacitance, gate to substrate capacitance. Okay, gate to this one, sir, gate to substrate capacitance, gate to, because there is no channel, after formation of channel we write that equation, gate to substrate capacitance. gate to substrate capacitance. So which is CGS, and fourth one is source to substrate capacitance. Substrate capacitance. So that is CGS. Sorry. Source to substrate or source to bulk capacitance, CSB. Okay, substrate or bulk. Fifth one is source to drain capacitance. Sorry, drain to bulk or substrate capacitance. Drain to bulk capacitance. So to avoid the confusion, I am replacing this by SB. Drain to bulk capacitance, that is CDB. Now this is going to be CSB and it is CDB. These are the total capacitances present in a MOSFET at high frequency. CGS, gate to source capacitance including overlap. Next, CGD, gate to drain capacitance including overlap. Next, gate to substrate capacitance, CGS. Next, CSB, source to bulk capacitance or substrate capacitance. Next, drain to bulk or drain to substrate capacitance, CDB. Okay, by considering all this, by adding all this, I am going to be representing MOSFET at high frequencies. Okay, now high frequency model of MOSFET or MOSFET high frequency model. MOSFET high frequency model. Before going to that, first at small frequency, at small signal equivalent, whatever the models we have, first we write that. So it is the gate, it is source, GMVGS, and R0 or RD. Source, it is the drain, it is GMVGS. Okay, and applying a voltage between gate to source, it is high frequency, that's why I am using capital letters for easy purpose. VGS. Now this is a small signal equivalent. Now I added a capital S, VGS. Now adding the capacitances to this. Between gate to source, we have gate to source, gate to source, gate to source we have CGS, and gate to drain we have CGD. First add that. CGD, CGS, After that, it is over, it is over. Next, CGS, CGB, gate to substrate. So that drain to bulk, drain to bulk, there is a capacitance CDB. Okay, and after that, source to bulk, we have another capacitance CSB. These are the capacitances. Okay, total 4 capacitances here we have, and so CSB dB, junction capacitances between the source and bulk, CSB, overlap capacitance, the source and bulk. This is the finally MOSFET at high frequencies. Okay, gate to source, CGD, gate to drain, substrate to bulk, drain to bulk. Okay, and device point of view, we represent this one like this. So G is equal to, just to take a MOSFET, so this is the drain, it is the source, it is the gate. Now the capacitances are, between gate to drain we have CGD, and gate to source we have CGS. Next, source to bulk we have CSB, drain to bulk we have CDB. Okay, this is the MOSFET at high frequencies. Okay, so you can expect the problems on this one also directly. Okay, next, I will take one circuit and what are the different capacitances present in that and are at high frequencies. Okay, now we go and check that. So first taking this circuit, so this is the circuit. Once you are in a position to write the different capacitances present in this at high frequency, you can easily write the high frequency, higher cutoff frequency of this one. Okay, now this is our circuit. Now we need to write the all capacitances present in this. So first I am copying this circuit. See this? In this circuit, first I am writing all capacitance present in this. So it is a gate, so gate, source, drain, drain, gate, source. Now just add the capacitors between gate to source, drain to gate to drain, CGS, CGD. First, similarly writing this. Okay, CGD. Let us, I am giving numbering to this. Let us take device 1, device 2. Now GS 2 it is, GD2, GD1, CGS1. Gate to drain, gate to source is over. Next, drain to substrate or bulk, drain to bulk, source to bulk, CSB1, CDB1. Similarly, CSB2, CDB2. This is the next level of the circuit. And from this circuit, we need to take high frequency. These are the capacitances present at each and every device. Now, once we are applying this one at high frequencies, some of the capacitors are not present. I will explain why they are not presenting. Say this. Now, once we are taking at high frequency, we need to take AC equivalent circuit. AC equivalent means a DC supply what we have also connected to ground. This is connected to ground. Okay, once it is grounded, it is ground, that means this is connected to ground, source connected to ground. Once it is connected to ground, this also connected to ground, no use of this. Similarly, now this capacitance CG2 is shorted by this connection. This is shorted, that's why no use of this. Okay, at the same time, source, this is connected, already connected to ground. This is and this terminal, both are at same potential, no use of this. Okay, by removing all those things, finally we have a circuit here. Now the next circuit is this is device 2, device 1, and taking output here. So finally what we have is, it is connected to ground from gate. So gate and drain both are shorted. That's why a capacitance CGS2 is connected from gate or drain to ground. This is CGS2. At the same time, it is no use. And another one, CDB2, another one, D12 base, CDB1, CDB1, and source connected to ground. You can connect this one to ground. Okay, and CGD1 is another one. Now these three okay, I'm writing that. Here is another capacitor. It is over, no use of it. And this one is CGS1 and another capacitance here. CGD1. Now this is the final circuit. Now I am going to taking this circuit. Okay, here we are writing output. Yeah, here we are writing output. Now the equivalent circuit of this one is finally these three capacitors are in parallel, can be replaced by a single capacitor, that is called output capacitance I am taking. Now the final circuit is VDD taking output. Now first C output capacitance, after that C GS1, because it is a device 1 and it is device 2, M2 M1, and here is another one, CGD1. Here applying input, and here C output capacitance is nothing but a CGS2 plus CDB2 plus CDB1. That's it. This is the final high frequency equivalent of the circuit. That means in terms of capacitances. Okay. So you should be thorough with that. After that, we are applying the high frequency analysis to our common source amplifier. Common source and common emitter amplifier. Just a minute. Now I am taking high frequency response of common emitter and common source stages. Common emitter and common source stages. Okay. First I am taking the regular stages. After that I apply the high frequencies present in that capacitance, different capacitances present in that. Based on that capacitances, I replace its high frequency equivalent model and write its input capacitance and output capacitance. After that, from that I write the with respect to input capacitance what is the higher cutoff frequency, with respect to output capacitance what is the higher cutoff frequency. Just write that. Okay, that is the thing, that is the process I am going to be doing now. Now first I am writing CE stage here. This side I am taking CE stage and this side I am taking CS stage. Simultaneously I am doing both. Now CE stage is a common emitter stage. So this is the common emitter stage. RS V input, RC plus VCC taking the output. Similarly CS stage I am taking. RG input plus VDD RD taking output. Now I want the different capacitances present in the device at high frequency. Okay, now I am going to that. Now I am adding the transistor capacitances. Transistor capacitances I am going to be adding. So in case of transistor we have between base to emitter we have C pi, base to collector we have C mu, and collector to ground there is a capacitance CS, CCS. Collector to substrate, a common substrate we are doing all this, that capacitance CS, CCS. In this, a drain capacitance, gate to source capacitance, gate to drain capacitance, drain to bulk capacitance, source to bulk capacitance, CGD, CGS, CSB, CDB. And once we are applying AC equivalent, next under AC analysis this capacitance is going to be missing. See this? In AC analysis, see this, it is grounded, it is grounded, so no use of this capacitor. Okay, no use of that capacitor. So only 3 capacitors are there finally. 1, 2, 3. Here also 3 capacitors. 1, 2, 3 capacitors. Now I am going to replacing this transistor as well as this FET by its small signal high frequency equivalent circuits. Now I am writing the small signal equivalents at high frequency. Small signal equivalent circuits. I am replacing transistor by its R-pi model. Now here is input. It is the RS. After that, now we are going to transistor. Here we have R pi and C pi. After that, there is a capacitance C mu. Here we have, and it provides a current, and at output we have RCA. Here we are taking output. This is our collector. This is C mu, C pi, R pi. Whatever the RB dash C, I am going to be omitting this because that is open circuit. I am taking GM into VB dash E. It is RCE. This is the base. Sorry, it is the emitter. It is base. Okay, it is collector. Now I am connecting that capacitors which are present in that. From base to ground, no emitter to ground, no capacitor. Base to emitter, and C pi C mu already we added. Addition to that, ground collector to ground we have CS. Okay. Okay, this is this is your RL. It is RL. Emitter connected to ground. It is RL. I am omitting that RCA. And here is a capacitor. CS, C pi and C mu. These are the capacitors. This is the input. Fine. This is our for transistor BJT. Okay, and now I am taking for, this is for CE. Similarly, I am taking for CS, common source. In case of common source, at input side same thing. V input RS. It is connected to gate, from gate to source. Source connected to ground. Between source to gate we have, gate to source we have a capacitance CGS. After that, gate to drain. Gate to drain we have another capacitance CGD, and here is a current source GM into VGS, and it is the drain. At the drain we have a load RL connected to ground. RL or RD, you can take it RD. Let us, we take it RC. And drain to this ground we have another capacitor C, D, B. If you observe this, both are seems to be same. To observe just one thing, in place of capacitive collector we have a drain. Okay, in place input RS. In place of base here we have a gate. R pi here you have in addition to that, but there is no R pi here. Okay, only that is the difference. And this is the voltage VGS. GMVB dash E, GMVGS, RL, CS, CCS, CDB. Now, by combining these two, I am going to writing a simplified equivalent model. By combining these two, I am writing a simplified equivalent model, and I am applying this one to that. And one more, we need these two models. After that, to relate these things, I do one thing. I am copying this. Because later we need these models. Okay, now I am taking the unified model of both the circuits. That means both the circuits are represented by a single model. Now, unified model of both the circuits. Unified model of both the circuits. Simple. So, input side, I am using V Thevenins, R Thevenins. Okay, and after that, input capacitance. Input capacitance. Let us take this is X terminal. From X terminal, and this is X terminal, and here I am taking Y terminal output. At output terminal, there we have a source, current source in both the case. So I am using a current source. Some that is a GM into input voltage Vx, because the voltage here is Vx. At the same time, here is a output capacitance and a load. Output capacitance and another load is present. Between X to Y we have another capacitance CXY. We have another capacitance. Okay. Now I am going to apply Miller's theorem on this capacitance XY. Okay, so it's equivalent at input and it's equivalent at output. I am going to be taking. Now I do one thing. Later I will add this. So here we added a capacitor CXY. Let us its equivalent input is CX and its equivalent output is CY. That means Miller equivalent. It's a Miller equivalent. After that we write the values. Here we are taking output. Here VH. Here is you are applying V output, taking output. This is next level of equivalent circuit. Okay. Now from this we need to write the equations. Now I am taking this capacitor, taking this equivalent circuit. This is the circuit. First I am writing Cx value. Cx is nothing but a applying this Cxy we have between this, that is a Cxy into 1 minus voltage gain of this. 1 minus voltage gain of this one is a Gm into RL dash. Gm into RL dash. So 1 plus Gm into RL you get without capacitors. That is Cx value. At the same time, Cy value is Cxy into 1 minus 1 by AV. So 1 plus 1 by Gm RL. That's it. This is the values of Cx and Cy. From the knowledge of Cx and Cy like this, I am going to writing the total input capacitance is now Cx plus C input. Therefore, C input total capacitance is, let us, I am taking it as, okay, we can write it as Cx plus C input. Similarly, C out total is Cy plus C out. Okay. Now, in terms of these capacitances, once you know these capacitances, we can write directly the pole frequencies. Now, higher cutoff frequency with respect to input capacitance, with respect to input circuit. Now, that higher cutoff frequency with respect to input capacitance is FH with respect to input circuit is FHI is 1 by 2 pi R is RTH into C input total. Similarly, with respect to output circuit is FH with respect to output circuit is 1 by 2 pi RL, 2 pi RL into C out total capacitance. Very simple. But we need one thing. This is the data what we have, but with respect to, but there in that analysis we are using RTH and VTH, CX, CY and Vx values. Now what are those values? In case of common emitter, V Thevenin's is equal to V input into R pi by R pi plus Rs. R pi by R pi plus Rs. Similarly, R Thevenin's is Rs parallel with R pi. And Cx is input capacitance. Cx is C mu into 1 plus Gm into RL is nothing but RC. Similarly, Cy is C mu into 1 plus 1 by Gm into RC. These are the values, and at this side VTH is nothing but a VGS or V input, because this is V input, gate current 0, that's why V input is VGS. At the same time, RTH is Thevenin's is nothing but RS only, and Cx is CGD into 1 plus Gm into RD. Cy is CGD into 1 plus 1 by Gm into R. Okay, this is the high frequency analysis of common emitter and the common source amplifier. Okay, this is the procedure to analyze the amplifier. Okay, is it fine? So next session we go and analyze the remaining amplifiers, common drain, common gate, like that. So here are the top educators from an academy. Tiwari sir, he is the IIT topper, having 7 years of GATE and ESE teaching experience, and he is the author of the book GATE in 75 days. He is the mechanical faculty. Ankit Goyal sir obtained All India first rank twice in GATE electrical, and he was awarded President of India Gold Medal in IIT Indore, and he teaches electrical and electronics engineering. Sanchit Jain sir, he is the computer science faculty, having a teaching experience of more than 8 years. Jaspal Singh sir, ex-IAS officer, having he got All India 4th rank in that, and he is the ex-senior MEDC faculty. Because of all these things, we are claiming that our educators are the top educators. Here are few more top educators from an academy, and now these are the different engineering disciplines available from an academy: electronics and communication engineering, chemical engineering, mechanical engineering, computer science and IT department, instrumentation engineering, electrical engineering, civil engineering, production and industrial, and for every department mathematics is compulsory. Okay, and general aptitude for engineering service and GATE also. Now there are two plans, plus plan and iconic plan. Already we know that. In plus plan, India's best educators are handling your subjects. Interactive live classes are there, structured courses and PDFs. And live tests and quizzes. The same thing you get in iconic plan also. What are the things you get here? The same thing you get, but once you written the test or quiz, it was forwarded to your personal coach. Your personal coaches do the analysis on that. We call it personalized test analysis, and based on that analysis, that means based on your performance in that, they prepare proper study planner as well as respect to study material to you. By following these two, every student can get success in their examinations. And after that, there are different subscriptions are there: 1 month subscription, 3 month subscription, 6 months, 1 year, 1.5 year, and 2 years. And the beauty is here EMI option also available, and by using my code you get 10% discount. Okay, 10% discount. Next, and in iconic plan, 2 subscriptions are there, 1 year and 2 year subscription. But here also, by using my code VRAO10 during subscription, you get 10% discount. Don't forget to use my code. And after this, don't forget to use my code VRAO10 during subscription. Hit the bell icon for getting notifications. Subscribers, please give your valuable comments on YouTube. Join our Telegram group for getting latest updates on our upcoming videos. So once again, I am welcoming you all to this beautiful online learning platform. And thanks for spending your valuable time with us. Thank you.